Now let's get to work on defining an optimal pig strategy. So we need a Q and a U function and an actions function. Let's get started on that. The Q function we'll call QPig. It takes a state and an action and evaluates the quality of that against the utility function. And what should we use for the utility function? Well, I think the best thing to use is the probability of winning, because we get 1 point for winning and no points for losing. That's a good way of thinking about the game. And so our expected outcome is going to be somewhere between 0 and 1, and that's like a probability. And so the probability of winning is our score. If we win all the time, the probability of winning is 1, then that should be worth 1 point. If we win none of the time, that should be worth 0 points. So our utility is just the probability of winning. And what is that? Well, if we hold, then we're turning it over to our opponent, and we still have our hold and roll functions that tell us what state we get to when we hold. And then it's our opponent's, and he's going to do his best. So our utility would be 1 minus the opponent's utility, what he can do best, his probability of winning, because either one player or the other has to win. So our probability of winning is 1 minus our opponent's probability of winning. If we roll, it's more complicated. If we roll a 1, then we pig out, and it's 1 minus our opponent's probability of winning because it's his turn. And otherwise, we just take all the possibilities for the other die rolls, and it's our probability of winning from the result of rolling in that state. And that's 6 probabilities altogether, so we have to average them, so we add them all up and divide by 6. And if the action wasn't hold or roll, I'm going to raise a value error. What are the actions in a state? Well, if there's some pending numbers, I can roll or hold, and if they're not, I'm just going to roll. That's the only thing that makes sense to do.